Hey there everybody, Cody from the Protocase team with another Proto Tech Tip. In today's video I'm going to give you some helpful tips for conductivity and custom enclosures. Conductivity is the ability for material to allow current to flow through it. Essentially, the best way to create conduction between parts is to have bare metal between the parts in contact with each other. So for electronic enclosure design, conductivity can be crucial, depending on the components housed within the enclosure and your organization's specific requirements. So since Protocase is a one-stop manufacturer of custom enclosures, parts, and panels, we can make what you need quickly to suit your specific application. When it comes time to creating conductive sections within your enclosure, there are a few key things to keep in mind. First, there's material choice. We recommend going with aluminum, galvanile, or stainless steel. We don't recommend using cold rolled steel. If left bare, which if you remember from earlier is required for conductivity, cold rolled steel will rust. Aluminum is corrosion resistant and lightweight. It does have a low structural stiffness, about 1/3, which must be compensated for by thicker gauge. Next material is galvanile. Galvanile is significantly more durable in wet environments, but it's not as durable as stainless or aluminum. And finally, we have stainless steel. Stainless steel is your best bet for corrosion resistance and has the same stiffness advantage of steel, yet even a higher strength. So moving on, let's talk about masking. Because unless you leave bare areas on your enclosure, you will not be able to achieve conductivity. So for masking, we apply thin polyester tape in specific areas in order to keep those areas free from having powder coat or anodizing applied. Powder coat and anodizing are both non-conductive, so if you didn't apply masking, your enclosure would not have conductive areas. So with masking, you have a few different options. You can mask the entire inside of an enclosure, mating surfaces of an enclosure, or areas surrounding connector cutouts, or areas under electrical components. As a rule, Protocase masks all internal and external fastener threads using silicone caps and plugs. We do not currently offer masking the inside edges of a cutout. Instead, you would need to mask both sides of the cutout. So if you're looking to achieve conductivity, masking will be your best bet for creating areas of bare metal between the parts. You can go with masking all mating surfaces, but just the spots around your fastener should work. In that case, we recommend making masked areas of 1/2 inch in diameter or larger. So finally, for conductivity, let's talk finishes. Remember, for conductivity, bare metal is key. So you can always opt for choosing a bare metal finish for your custom enclosures or parts. You can choose no finish, which means the part is deburred to remove sharp edges with no additional finishing, so you should expect minor surface scratches, swirl marks, and blemishes. If your enclosure or parts will be on display in any professional manner, we don't recommend opting for no finish. Instead, we would recommend using a grain finish, vibratory finish, or media blasting for your parts if you prefer a bare metal look. For grain finish, a part is deburred then a specific linear grain direction via brushing. Vibratory finish smooths and imparts random finish via tumbling in abrasive medium. For media blasting, the part is deburred and cleaned, then sprayed with a steady stream of tiny glass beads via compressed air to create a smooth, uniform finish that's flat and non-directional. So check out our website for a full breakdown of each of these bare metal finishes and their constraints. So beyond our bare metal finishes, you can also choose from Chem film, anodizing, or powder coating. Chem film, also known as chemical conversion coating, is a coating process that applies chromate to aluminum, creating a surface that is corrosion resistant, durable, and exhibits stable electrical conductivity. It is an excellent choice if you want to use aluminum and get great corrosion resistance as well as reliable electrical connection between parts. Anodizing is an electrochemical process wherein aluminum is placed in a liquid bath with an electric current flowing through it. This produces a chemical reaction that thickens the oxide layer on the surface of the aluminum, which in turn increases the aluminum's durability while also allowing for electrical conductivity. One caution with anodizing, this finish is completed off-site by a third-party supplier, so there will be additional lead time and cost. Then we have one of my personal favorites, powder coating. Powder coating is an excellent way to add corrosion resistance, durability, and protection to your part. We offer a wide range of powder coat colors and texture options, which will give you a vibrant, professional look that will make your parts stand out. So remember though, if you are looking for electrical conductivity and want to opt for powder coating, masking either select areas or the entire inside of your enclosure will be essential. So before we finish off, I just wanted to touch on copper bus bars, which we also make here at Protocase. Copper bus bars are typically put into a custom enclosure or a board so that it distributes a significant amount of current. Copper bus bars can be part of a fully custom enclosure design or a standalone part. We also offer tin plating, which will improve the corrosion resistance, electrical conductivity, and solderability for copper bus bars. Similar to anodizing, tin plating is completed through a third-party supplier for additional lead time and cost. So that covers all of our tips and guidance for conductivity in metal enclosures and parts. Many of the topics we touched on today have been covered in previous Proto Tech Tips. We've got a full list linked below, so check those out. So thanks very much for watching this week's Proto Tech Tip, guys. If you have any questions, leave a comment below or reach out to us at info@protocase.com. We hope to see you back here next week.